Welcome to the next set of notes. Our title is as listed. Should be getting used to this process. Our title is 2-4, solving equations with variables on both sides. And we'll put our date off to the left on our note paper. And we will jump right in, trying to keep these videos short. So the first situation we look at is a new situation, naturally. We've got It looks pretty easy. I mean, it's just 2 terms here equals 2 terms here. But the issue with this one is we've got an x on each side of the equal sign. Now, a lot of students, I'm going to go to red. Make sure you remember red means you don't write. I like to show things like this. A lot of students try to do this. They try to put those together like that. That can't happen because there's an equal sign here and you cannot go through this equal sign. So a lot of students will try to combine like terms, but this is not where you combine like terms. What you should do, though, is that inverse operation stuff. And what that means is you're making things essentially disappear. So you've got a 2x here and a 5x here. It is actually your choice what you want to make disappear. It will work either way. There is no wrong answer, but there is an easier way. So I'm going to pick the smaller one because I know it's going to make the numbers a little nicer. So I choose to get rid of 2x. I need to get rid of this right here. So the way I do that is I subtract because that's a positive 2x. And a lot of students get a little confused here because they're like, it feels like a division thing, but no, you need to make the entire and I'm going to put the little plus sign there. You need to make the entire positive 2x disappear. The only way to do that is to take away 2x, just like this. Now, remember the scale. We did it on the right side here. We're going to have to do it on the left. So what do I do? The only one it matches up with is this one. So I put it underneath the negative 2 underneath the 5x. You cannot take away 2x from 2. You cannot take away 5x or 2x or any x away from these numbers because they don't have an x. Those are old algebra rules. So we have to do it from these. Now, what happens here, essentially? This is important. This becomes 0x, or effectively nothing at all. 0x is a 0. So guess what? It's just like we used to do when we add and subtract. We slash the whole thing. So I want to repeat. If you have an x on each side, you need to cancel one of them. Take your pick. It doesn't matter which one, but you have to basically get rid of one of them. So I chose this one. Now we got to get back to our problem here. 5x minus 2x is 3x. Those are like terms. They go together nicely. The plus 2 will drop. Keep everything orderly, please. The 14 is still over here. It drops. Now this is going to feel a lot like the old problems. So this isn't too bad. We've got a plus 2 hanging on here. We'll take care of that at this time. To get rid of a plus 2, we do a minus 2 to each side. And we cancel the 2's. The 3x falls, equals falls. 14 minus 2 is 12. And then how do I detach the 3 from the x? Or how do I undo this multiplication? I divide it. To detach it, I divide it. Becomes a 1x equals 4. So, the difficult part of these problems is simply, what do I do when I have an x on each side? And when it looks like this situation, you want to basically cancel one of those x's through addition or subtraction, not division or multiplication. That's a common error I see. Okay, well, we've got an x on each side, but we really can't do the addition and subtraction right now because these aren't technically done yet. You have to kind of finish these expressions because they've got a distributive property waiting to happen here. So let's go ahead and do that. So what I want you to do, I want you to circle this number, and I see there's no sign there, but there secretly is a little plus sign there. So I want to distribute a positive 2 to the 5x and to the negative 1. And I'm going to go ahead with my notation. I'm going to circle the 3. Put the little plus sign there. I'm going to distribute to the x and to the 11. And remember, this shows all of our work. It makes very good sense if we do this so we see what we're doing. We are multiplying when we distribute. Here we go. 2 times 5x is 10x. 2 times negative 1 is negative 2. So I've got 10x minus 2 equals 3 times x is 3x. 3 times 11 is plus 33. And I've got a problem that looks just like this one did when we started. Basically, we've got an x on each side. And it looks just like it. So we're going to do the same stuff. We need one of these x's, these x terms to go away. I'm going to choose the smaller one again. It makes life a little easier. So how do I make this entire thing go away or disappear, become a 0? Do the opposite operation. It's a plus 3x. We will do a minus 3x. Now, where else? I know I have to do it again somewhere, right? And where exactly? Well, you did the right side of the scale. Now you do the left side. And it only matches up with the x term over here, so minus 3x. You can't take away 3x from 2. I see that a lot. That's gone just exactly like we wanted. That's the whole purpose why we did it. Let's put these x's together now and get a 7x minus 2 equals 33. We will look at this now, and it looks very familiar. These problems get very repetitive once you do a bunch of them, which is a good thing. That means you're getting it. So we take away we basically get rid of the negative 2 by adding 2. That becomes our 0. 7x will drop, equals will drop. You'll end up with 35. 7x equals 35. We have to divide each side by 7. That becomes a 1x, a 1x, I should say. X equals 5. Very nice. So a lot of work there. You see my notation, and I didn't even show the check here. Please do good notation. So it's very easy to mess up on these problems. But the big story today is about how do I get rid of an x if it's on each side. And as you're seeing, I'm adding and subtracting those x terms. Let's see what we have on this one. And I see a distribution problem here, so I'm going to go ahead and start with that. That's where I always begin. So it's a plus 2. I'm going to show my plus sign there. I'm going to distribute it in. Now, I'm just going to drop this. I'm not going to touch it in this step, so I'm just going to rewrite 10x plus 12 equals. Then I'm going to distribute this 2. So 2 times 5x is 10x plus 12. Well, wait a minute. Something looks a little strange here. It looks like the same thing, and it is. This is a special case, and it has special rules. So this is a bit tricky. I'm going to show you how this works here. But this is where you see the exact same thing, even with the signs. You got to make sure the signs are the same and everything. I'm going to go ahead and continue the problem like we have been, but there is something that's about to happen here. So since these are both 10x's, I got to get rid of one of them. It doesn't really matter, I guess. So I do that by minus 10x on each side. That makes that go away. But wait a minute, it also makes that go away. So I'm left with 12 equals 12. And then if I really want to continue the problem, which you don't even have to keep going, but I would take away 12 on each side. Now it's getting a little confusing. I'm probably assuming that's what you're thinking. 0 equals 0. Well, that is a very interesting problem here. And it has an answer to it. If 0 equals 0, you actually have an answer of infinite solutions. Or there's another way to write it. I'm going to write both ways. All real numbers. And what in the world does that mean? And I hope you've been checking your work a bit, especially in those earlier lessons when it was easy, because here's what it means. Your final answer, by the way, is this. It's everything. It's any number in the world you pick will work. What are we trying to do here? So I'm going to go ahead and erase this. You keep this for your notes. That's what we need. But I'm going to erase it so it doesn't look so confusing. If everything's an answer, just pick a number. I'll pick the number 2. Let's make this kind of easy. I'll pick 2. So I'm going to claim that x is 2. If I put a 2 here and a 2 here, the thing should stay balanced. So let's see. What's 10 times 2? We'll show my work real quick here. What's 10 times 2? That's 20. 20 plus 12 is 32 on that side. Okay, so I put a 2 here. 5 times 2 plus 6, close it up. So I get 16, so it's 10 here. 5 times 2 is 10. 10 plus 6 is 16. 16 times 2 is 32. Well, wait a minute, it did work. 2 worked. What if I put in x equals a 1 or x equals a negative 50? I'm not going to show you all these, but it does work. I could even put in x equals negative 14 over 3. If I plug in negative 14 over 3 on these two x's, I will get a balanced answer. So I want to kind of erase this slide. If you ever get down to the identity, that's what I was kind of saying. When we got to this step here, we should have said, wait a minute, these are the exact same thing. This is where you see the identity. And here you can immediately, you don't have to go further like I did. As soon as you do this, you can just say all real numbers. And we're not going to discuss what real means in this lecture, but in future ones, we may cross that bridge. But all real numbers as soon as you see this setup. All right, let's look at the next one. So this one, I'm going to go ahead and skip this one. I want to show you, yes, this is the one I was looking for. So let me show you another situation. We're going to distribute this positive 3, and we're going to get 12b minus 6 equals minus 6 plus 12b. Now, we got to be a little careful here. Are these the same problem? They don't look identical. But if we use our properties from the past, I'm going to rewrite this side. Am I allowed to switch these two? The answer is, well, let's think. We're adding them, right? Are we allowed to switch numbers when we add them? The answer is yes, but you got to be very careful. For example, 3 plus 2 and 2 plus 3 are the same answer, right? They're both 5. So I can actually switch these. I just got to be very cautious. So if I put the 12b first, this is the sign that's with the 12b. So 12b, I'm not going to show it, but there is a secret plus sign there. And then this is the sign that's always with the 6. Now, if you look at it, is it the identity property? Are these the exact same? I'm just going to clear this up here. Are these the exact same? The answer is yes. So this is all real numbers again. I just want to show you that sometimes it's disguised. Sometimes, like, you don't realize it's the identity on that step, but when you rearrange it, you realize it is. There's just one other situation I want to cover, and it is this situation here. I'm sorry, it's not this one. It's back here. So let's take a look at this situation. 9m minus 4, I'm going to rewrite because I won't be touching that right here, because I have to combine like terms over here, and I will get 9m. So negative 3m plus 12m, that makes 9m. Now I've got this plus 5. And I want you to look at this. Is this the identity property? We've got 9m minus 4, and we've got 9m plus 5. The answer is no, it's not the identity property. So I'm not really sure what to do right now. If I'm a student sitting there, I'm thinking, it's not all real numbers for the answer. So what should I do? Well, let's continue. Let's just show our work a little bit more, like I did the first time we saw something like this. Let's get rid of these m's, just like the lesson tells us to. And goodbye, goodbye. We're left with negative 4 equals 5. And there's where I'm going to stop. A lot of people are very confused, like, wait a minute. Negative 4 does not equal 5, and you are absolutely correct. Negative 4 does not equal 5. So I have a very, very fast way to remember this. This makes no sense. If you ever lose the variable like this, see these 9m's went away because we had to subtract them to get rid of them. But since they were the same on each side, they both went away. And we're left with two numbers that don't equal each other. This makes no sense, so I like to write makes no sense. And the answer, that's how I remember, is no solution. So my final answer is no solution. And then once again, you're probably like, okay, what in the world does that even mean? Well, I get your confusion. Let me go back to the check phase. Checking answers is not just busy work. It helps us understand what we're even doing. So I'm going to erase the board again. We're claiming there is no answer. So if I erase the board, what in the world are we even trying to do when we're doing all this? We're trying to figure out what m is. That's the whole purpose of what algebra is. We're trying to find these unknowns. We're saying there is no answer. So if we claim, well, I think there's an answer maybe out there, m equals 2, and I'm just guessing a 2, and I go ahead and plug in a 2, I'm going to go ahead and do that. 9 times 2 minus 4 equals, my pen is acting up, negative 3 times 2. This is, you gotta be very careful. Plus 5, plus 12. Now, where did I come up with that 2, by the way? I'm sorry, you might be confused. Where did I come? I just made this 2 up. This m equals 2. There is no answer to this, but I'm just giving us a number that we can plug into these m's. So let's go ahead and I'm going to solve this out for you real quick. 18 minus 4 is 14. Negative 6. So negative 6 plus 5 is negative 1. Negative 1 plus 24. So it would be 23. Does 14 equal 23? Of course it doesn't. And I'm just not going to waste any more time. It doesn't matter what you said m was. M is not going to be 4. It's not going to work. M is not going to be 5. M is not going to be anything because there is no solution. So let's just recap these 2 special cases because I know they're tricky. If you get an identity, something, and I'm going to go ahead and I'm going to go off the slide here. I'm going to go ahead and show you a problem here. If you get this, 3x plus 2 equals 3x plus 2, remember, this is all real, and I'm going to have to abbreviate, numbers. If you get 3x plus 2 equals 3x, I don't know, plus 4, this is no solution. If you recognize them early on in the problem, you can stop right when you get to these steps. You see that these are identical in these problems, and you're like, okay, it's one of these special cases. So take a look, watch out for those. They happen, but they don't happen often. I know I spent a long time on that, but that's a confusing topic. What I really like you to focus on is more on the problems we already did like this, where that there's a 10x and a 3x, and they're not going to both disappear. So those are the kind we're going to focus on today. And that was a long set of notes, but I'm probably going to make this over 2 days. So take your time with it and hit that pause button as you need to.